Hello and welcome to another tutorial on dev.java website, and we're looking at the primitives, and we look at the primitive literals. And now let's look at using underscore characters in numeric literals. And I mentioned this before, that Java allows you to add underscore whenever you have a numeric literal like floating point, integer, long, double, etc. Even in the hex format or binary format, doesn't matter. Java allows you to use underscore, and basically in the source code the compiler basically ignores these underscores. It's like these underscores are invisible to the compiler. I believe you cannot start the number with an underscore, so the first character of the numeric literal should be a digit, right? It cannot be like a underscore. In Java Standard Edition 7 and later, any number of underscore characters can appear anywhere between digits in a numerical literal. This feature enables you, for example, to separate groups of digits in numeric literals, and typically for decimal we just separate them every 3 digits, which makes it much easier to read and understand in the source code, which can improve the readability of your code. So again, these underscores don't have any meaning at runtime, or don't have any meaning to the Java compiler. Java-C basically completely ignores these underscores. These are just for readability of your source code. For instance, if your code contains numbers with many digits, you can use an underscore character to separate digits in groups of 3, and this is mainly true for decimal numbers, like numbers you write in base 10. If you write hex or something, maybe you want to separate each 2 digit would represent 1 byte. Remember, in hex every character or digit here represents 4 bits. Same with, for example, binary. Maybe you want to separate every 4 bit or every 8 bit, which represents a byte in this example, for example, right? So if your code contains numbers with many digits, you can use an underscore character to separate digits in groups of 3, similar to how you would use a punctuation mark like a comma or a space as a separator. So the following example shows other ways you can use the underscore in numeric literals. So a long, we said that long literal, you have to suffix them with capital L or a small l, and we said that a small l is not recommended because it looks like a digit 1. So for long we always recommend to use capital L. And here it's an example that we just, maybe every 4 digit we put an underscore. This is completely invisible to the Java compiler, right? This is a long, again, it's the suffix is capital L, otherwise the compiler will consider an integer literal, and integers cannot be implicitly converted to long. Then therefore if you don't put L here, you get a compilation error. Float pi, and again floats, decimal floating point numbers, the default is double, so if you don't put capital F or a small f here, the compiler will consider it a double. Right, so we have to suffix it with a capital F or a small f. As you can see, we put an underscore here to differentiate or basically group the floating digits or the decimal digits. A long hex, again hex literals are prefixed with 0x. Capital X or small x, the convention is to use a small x, that's fine. And we are separating each byte. Each one of these characters represents 4 bits, so 1 byte, 2 byte, 3 and 4 bytes. And then you see this is the magic hex number in Java classes Cafe Babe. So every class, when the Java-C compiles your Java source code and creates one or multiple class files, every class file after the compilation has this magic word Cafe Babe in it, right? It's a hex, and it's basically 2 bytes, right? Max long, again in the hex format we are typing binary. 0b means binary, and 4 bits, this is 1 byte, right? 8 bits, and we are using underscore to group every 4 bit. And for long in a binary format we are separating bytes, right? Every 8 bits we separate them with an underscore for more readability. So if we go to let me just put back this code here. Let's call this public static void test5, and I am going to copy and paste all these discussion that we had about floating point literals, string and character literals. And now let's look at the basically underscore. So we can say for example this one long right? And then again, if we sys it out, we do a sys out, use the println function, has word. We're not going to see the hex representation. That's just because the println converts, when it calls the console, it converts to decimal, right? So if we want to see the hex representation, again, we have to use the integer to hex a string. We have to convert it to a string that represents the hex value, hex word. And this complains because this expects an integer. Let's see if the line class has this. Yes, the line class also has this 2 hex string, and it accepts a line literal or line primitive. And we say FFFFF cafe babe, right? And so as you can see, all the bits are 1 here, and so everything is 1, and then we get the cafe babe, right? All right, let's go back here. So you can place underscores. One thing that I want to mention in a modern C++, so in modern C++, what they did, they added single quote instead of underscore. So if you're familiar with this underscore notation in literals, in modern C++, you can, for example, in Java, you can, let's look at the, for example, 1, 2, 3, 4, 5, 6, 7, L. All right. And if I run this, right, we get 1, 2, 3, 4, 5, 6, 7. In modern C++, let's say you want to, in Java, you can group this by every 3 digit for ease of, so that you can easily read this. In C++, you say hex word, for example, is, instead of underscore, they added the single quote. So you can say 1 single quote, 2, 3, 4 single quote, 5, 6, 7, something like this. So in modern C++, you don't use underscore, you use a single quote. In Java, you use underscore, which has been with us from Java 7, which is quite a long time. So you can place underscore only between digits. You cannot place underscore in the following places: at the beginning or end of a number. So if we go back here, let's call this x1. Let's remove these underscores. So this is a valid line of code. It compiles fine. If I add underscore here, it's going to complain and says that, let's see what it says. Underscore 1, 2, 3, 4, 5, 6, 7, 9 cannot be resolved to a variable, right? So it doesn't understand that this is actually a long literal because of the underscore. Now, the name of the variable can start with an underscore, so this is fine. So name of a variable can start with underscore, but this is discouraged, and I believe in the latest version of the Java JDK, they try to make this a compilation error. So they try to reserve the single underscore at the beginning of the name variable as some sort of internal to the JDK, this kind of stuff. But for now, if you're using Java JDK 16, you see that it compiles fine. But the thing here is that basically a literal or a numeric literal cannot start with underscore, because if you add this, the compiler actually assumes that you're trying to define a variable, and this is not a variable, right? Not a correct long, it's not a variable because you're suffixing it with capital L, which means this capital L or this suffix only is allowed on the literals. And then when you add underscore, the compiler assumes that you're trying to define a variable. So that makes a compilation error. Adjacent to a decimal point in a floating point literal. So if I say float x2 is 3.14, this one is doesn't compile because it assumes that you're trying to define a double. So let's say a small f. So it says that you can put underscore anywhere in a float literal except adjacent to this decimal point or this dot, which makes sense, right? So if I try to put a underscore here, you see that it doesn't compile because it doesn't make any sense to have an underscore right after the decimal. Same here, even before that, it doesn't compile. I cannot put it here because it cannot start with an underscore. If I have 2 digits, I can put underscore here between these 2 digits. or I can put an underscore here. That's also valid. Anywhere except for the beginning of the floating point number and next to the decimal point, either before or after it, it's not allowed, right? Again, this underscore business is making your literal more readable. So if the dot is already there, there is no point of having an underscore after that, because the dot already indicates that how the decimal point and the fractional part are separated. Prior to an F or L suffix, which makes sense. What's the point of putting an underscore at the end of the number? I mean, this doesn't make any sense, right? So, and the compiler doesn't allow you to do that because it doesn't make sense. It doesn't help with readability in positions where a string or digit is expected. This is also something that you should be aware of. So the following examples demonstrate valid and invalid underscore placements in numeric literals. Invalid, cannot put underscore adjacent to a decimal, right? So you cannot put it before or after this dot decimal point. Invalid, cannot put underscores adjacent to a decimal point after the decimal point. So the first one is before, the second one is after the decimal point, because it doesn't really help with readability, because the decimal point already indicates how the two parts of the floating point are separated. So they decided not to allow these. Invalid, cannot put underscores prior to an L suffix. Again, adding an underscore here right after all the digits doesn't help with the readability, and it doesn't make sense. You want to make sure that this L sticks to the last digit, right? Okay, decimal literal, yeah, this is an integer. We can put underscore anywhere except for before the first digit or after the last digit. We cannot do that. Cannot put underscore at the end of the literal. We cannot do this. Okay, decimal literals. And now interestingly, this is also allowed. So let's look at this. You can have more than one underscore, and again, underscore is completely invisible to compiler. So all these underscores are invisible to the Java-C, which means when Java-C compiles this line, it just ignores everything here, and it just sticks these two digits together, 5 and 2, and it assumes that it's an integer. So it just writes 52, right? So there is nothing. So the Java compiler completely removes this underscore. So so you can in fact use more than one underscore, right? 2 underscore or more than, or 1 underscore. Obviously the convention is that or the best practice is to use only 1 underscore. So use only 1 underscore, because having more than 1 underscore is just doesn't look nice, something like this. Invalid, cannot put underscores in the 0x when you're defining radix. So what's the point of having 0 underscore x? It doesn't help with readability, so it's not allowed. Cannot put underscores at the beginning of a number. Again, 0x is basically not part of the number. It's part of the declaration that, hey, we are declaring a hex number. So the same rule applies, right? You cannot put underscore before the first digit of the number. And when you're defining binary or hex, 0x or 0b, it's not part of the digits of the number. It's part of the declaration of what kind of type we're defining. Is it a decimal or hex or binary, right? So the first digit of a hex declaration is still this 5 here. Okay, hexadecimal literal. So again, 0x is not part of the digits. So again, the digits here are 5, 2, and we can put an underscore in between the digits. Invalid, cannot put underscore at the end of the number, and again, the digits are 5, 2, and we cannot have underscore after the last digit, right? So these are the things that you need to be aware of. So this was the entire discussion on creating primitive type variables in your program. Now, if we go back to the Java language basics, we look at item 1, creating variables and naming them. Item 2, creating primitive type variables in your program. So now that we have this understanding, we're going to move on to item 3, which is creating arrays in your programs. And the nice thing about arrays is that Java decided to support linear arrays, very similar to the arrays that are built-in types in C and C++. So C++ kept the array type just because of being backward compatible with C, but in the modern C++, they're trying to move away from the built-in array types because Those are just types that you can't really do any dot operation. They're not treated as objects in C or C++. In Java, linear arrays or primitive arrays are treated as objects, or the JVM gives you this illusion that they are. So you have some dot operations on them. You can inquire the length of the array, etc. So I will leave this for the topic of the next discussion. I hope you enjoyed this one. Please stay tuned, and I'll see you in the next one.